What if the Milky Way is not a quiet, empty spiral of stars, but a galaxy teeming with thousands of civilizations, some ancient beyond imagination, some perhaps watching, waiting, or simply too far away to ever reach us? This is not science fiction. This is a question that some of the most respected scientists on Earth are actively trying to answer. And the mathematics behind it might genuinely surprise you. To understand why this question even exists, you first need to grasp the sheer scale of our galaxy. The Milky Way contains an estimated 200 to 400 billion stars. Let that number settle for a moment. 400 billion stars, each one a potential sun, each one potentially surrounded by its own family of worlds. Based on data gathered over the last 2 decades, astronomers now believe that most stars host at least one planet. That means there could be hundreds of billions of planets in our galaxy alone. Among those, a significant fraction orbit within the habitable zone of their star, the region where liquid water, one of the fundamental ingredients for life as we know it, could exist on a planetary surface. Conservative estimates suggest there are tens of billions of potentially habitable worlds in the Milky Way. Tens of billions. And our galaxy is just one of roughly 2 trillion galaxies in the observable universe. The universe, it turns out, is extraordinarily generous with planets. The Drake equation was not designed to give a definitive answer. It was designed to frame the question. It breaks down the probability of detectable extraterrestrial civilizations into a series of factors: the rate of star formation, the fraction of stars with planets, the fraction of those planets that could support life, the fraction where life actually emerges, the fraction where intelligence develops, the fraction that developed technology capable of communication, and finally, the length of time such civilizations remain detectable. Plug in optimistic values, and the equation suggests there could be thousands, even millions, of communicating civilizations in the Milky Way right now. Plug in conservative values and the number drops dramatically, potentially to just 1, which would be us. The equation does not give us a clean answer, but it forces us to confront the variables. None of these explanations has been proven. All of them remain on the table. If the numbers suggest that life-bearing worlds should be common, if intelligent civilizations should have had billions of years to develop and spread across the galaxy, then where is everybody? This is the Fermi paradox, named after physicist Enrico Fermi, who in 1950 asked a deceptively simple question during a lunch conversation. Where are they? A civilization even a few million years more advanced than ours could theoretically colonize the entire Milky Way within a cosmically short time frame. We should see evidence, signals, megastructures, something. But our skies remain silent. Scientists have proposed dozens of explanations. Perhaps intelligent life is extraordinarily rare, and we are among the first. Perhaps civilizations tend to destroy themselves before reaching the stars. Perhaps they are out there but deliberately silent, or communicating in ways we cannot yet detect. The search continues, and it is more sophisticated than ever. The search for extraterrestrial intelligence, known as SETI, has been scanning the skies for artificial radio signals for decades. More recently, scientists have expanded the search to include what are called technosignatures, detectable signs of technology such as unusual atmospheric chemicals, artificial light patterns, or anomalous energy signatures around stars. The James Webb Space Telescope, now operational, is capable of analyzing the atmospheres of distant exoplanets with unprecedented precision, searching for biosignatures like oxygen, methane, or other chemical combinations that life tends to produce. No confirmed signal has been received. No confirmed biosignature has been identified. But the tools we now have are more powerful than anything that existed even 10 years ago, and the search is still in its early stages. We are a species that looks up at 400 billion stars and asks, with complete sincerity, Are we alone? The honest answer is that we do not know. The mathematics of the universe suggests that life, and perhaps even intelligence, could be widespread. The silence of our instruments suggests either that we are looking in the wrong way, that the distances are insurmountable, or that something about the emergence of complex life is far rarer than the numbers imply. What science can say with confidence is this: the conditions for life exist across the galaxy in staggering abundance. What it cannot yet say is whether those conditions have ever produced anyone else. Every answer we find seems to open 10 more questions, and perhaps that is the most human thing about this entire search.